So let's take a look at what they're asking us here. So problem 2, they're asking us to find all three of these currents. So find I1, 2, and 3, and they define I1, 2, and 3 for us here. Okay, and we see that we've got a battery along with 3 resistors, 4 resistors. And let's see what's right what we know. So we know we have V of S. We have all of our resistor values. Do we know the current for the entire system? Not quite. So what we'll need to do is go and figure out what that current is, because we need to figure out what the current that's being split up is. Now, there's a few ways we can go about doing this, but we're going to go about what I think is the easiest way. So to find I1, so we need to know what I1 is, because we see from here that I1 is going to enter and then break up to form I2 and I3. So I1, I2, and I3. So let's find I1 first. So to find I1, we can say V is equal, or V over R. But to do that, we need to say it's V of S over R equivalent. So how do we do R equivalent? We'll have to take this entire circuit and then break it down to one resistor and one voltage source. So to do that, we'll say that these two are in series, so that's series 1. So R series 1 is equal to R of 3 plus R of 4, which is 15 plus 25, which will give us 40 ohms. And we're going to make this drawing a little bit smaller. So this is R series 1, this will be R2, and that's R1 up there. And we'll see that these two are in parallel, so I'll call that parallel 1. So R parallel 1 is equal to R2 times RS1 over R2 plus RS1. And since there's only 2, that's why we can do this. So R2 is 40 times 40 of RS1 over 40 plus 40. So R parallel 1 is going to be equal to 20. So 20 ohms. And then lastly, we have R1, R parallel 1. And we see that those two are in series. So I'll call that series 2. So this will be R series 2 is R1 plus R parallel 1, which is 10 plus 20, which will give us 30 ohms. So our R equivalent is equal to 30 ohms. Plus minus. Okay. And notice, so here, the current I1 is staying the same the entire way. Okay. It's just leaving that battery. We haven't changed it from there. So that's why we can do this V is equal to IR. So V is equal to IR. Therefore, I is equal to V over R. And we know it's going to be V of S over R equivalent, which is going to be equal to 30 over 30. So I1 is going to be equal to 1 amp. All right. So we get the first part of it. So now we know I1. But now we need to find I2 and I3. So let's look at I2. So I'll say I2. If we know we're going to come in here and then break off and go that way and then break off and go that way, and we see it's going to two different branches, we can see that that's going to be a current division. So current division. So what do we need for the current division? We're going to need R equivalent over R2 times I of S. Okay, and something to note is the R equivalent is only going to be what you're combining in parallel. Okay, so it's R parallel of only these two branches. Okay, you can imagine that this side doesn't even exist. It's only what you're using to break up the current. Okay, so like we said, this is going to be R parallel, but we already found R parallel. It's you know, right there. So we can say R parallel 1 over R2. Now what's I of S going to be? Well, I of S is the source current. That's what's being broken up. So in this case, I of S is equal to I of 1. So I of 1. So we'll do R parallel, which is 20, over R2, which is 40 ohms over ohms. And we'll multiply by 1 amp. And when we do that, we will get I of 2 is equal to 0.5 amps. So now we found I of 2. So now all we have is 1 left. And something that's cool that we can do is there's actually 3 different ways you could go about this to find I of 3. I'm going to scoot up just a little bit. Okay. So the first one, I'll say, method 1, will be just to do the exact same thing we did for I2. So I of 3, it's just the current division. So 1 is the current division. So if we do a current division, we can do R parallel 1 over R series, because it's the equivalent of what that branch is. So it's everything that's on this branch. So it's R series 1 is what you're going to have to use. So over R series 1 times I of 1, which will give you 20 over R series 1, which was 40 ohms over ohms, times 1 amp, and that will be 0.5 amps. That's I of 3. Okay. And then I saw someone in the chat say, what about KCL? And I say, you're absolutely right. We can do KCL. So if we did KCL, which was like this, I1, I3, and I2, and we say that I1 is equal to I2 plus I3, therefore we can say 1 amp is equal to 0.5 amps plus I3. So therefore, I3 is equal to 0.5 amps. All right, and that's method 2. Now for the third method. The third method is going to be parallel branches. And I'll scoot just a bit. Okay, so 3, we see that it's the prettiest circuit I've ever drawn. If we have R of 2 and then R series 1, like we said, these two are in parallel with each other. And a key concept in this course is parallel branches have the same voltage. Okay? Live it, learn it, love it. And that goes back to what we were talking about before with voltage along the wire is the same. So the voltage here is the same as the voltage there. So if we were to pass through and hit the bottom here, the voltage here is the same as the voltage there because they're on the same wire. Okay. So anyway, what does that mean for us? So we know that we can find the voltage across 2 from V is equal to I2 times R2. And that'll give us I2, we said was 0.5 amps, and R2 we said was 40 ohms, which will give us 20 volts. And because these branches are in parallel with each other, V of 2 is equal to V of RS1, which is equal to I of 3 RS1. So therefore, I of 3 is equal to V RS1 over RS1, which is 20 volts over 40 ohms, which is once again 0.5 amps. Okay, so this example just goes to show you that there's more than one way to solve these problems. It's really what you're comfortable with and whatever you think solves the problem the fastest and the most efficient way. Does anyone have any questions about this specific problem before we move on to the third problem?
Yeah, I have a question.
What you got?
Is there a fourth way that would be a lot easier by using a KCL? And since if I is the input and then I2 and I3 are the output, you knew I1 was 1 amp and you knew I2 was half an amp. So didn't I3 have to be half an amp to add up to 1?
Yeah, and that was the second method that we have right
Okay.
there. Right
Oh,
there.
my bad. Sorry. I wouldn't. Okay. I see.
No, you're good. You're good. Um, yeah, and that's a good point. That's a good point to bring that up. And I want to point this out to you. Notice how much resistance is on both sides. So when we combined it down, like we said, this was 40, and we said this was also 40. And we talked about that concept of current wants to follow the path of least resistance. Okay. But if both paths have the same exact resistance, it's going to split the current up evenly. So it's kind of like if you're heading down a hallway and you have 10 people on your left side and 10 people on your right side, you don't really care which way you go down. But if you had like 5 people on your left side and then 10 people on your right side, you're going to want to go down the side where there's less people. So that's just kind of a way you can visualize it. But yeah, are there any other questions about this problem? All right, seeing none, so I will move on to the third problem.